This is problem 9.6.41. We're supposed to find the integral of dx over 9x minus 15 cubed from negative infinity to 1. Now, first of all, when you see a problem like this, it's one of my little personal pet peeves when people typewrite it, where they put the dx on top of the fraction. There's nothing wrong with it, it bugs me personally. So rewrite this as 1 over 9x minus 15 cubed, and it might make a little more sense that way. Or we might go even a step further and say this is 9x minus 15 to the negative 3 dx. That's the easiest way for us to then take the integral. Now at this point, I look at this and I'm saying, okay, this is 9x minus 15. I'm going to have to use u substitution. We'll come over here for my u substitution. And I'm going to say u equals this 9x minus 15. The derivative of that would just be 9. And we can solve for du and say du is 9 dx. Now coming back to this problem over here, notice there's not a 9x in there, or a 9 dx. There's a dx, but there's not a 9, so we need to add in the 9. But if we do that, if we multiply by 9, we need to multiply on the outside by 1/9, and then those will cancel each other out, so we're not actually changing it. So the 9 and the dx together make my du. So let's go ahead and substitute. And so we're going to have 1/9, the integral. Let's see, that 9 dx just becomes du. And so this is really just u to the negative 3. Now there's a few different ways you can do this. You can change these x limits to u's, or we can just kind of wait until the end and try and plug them back in. And I might do that because you might be confused about how to do 9x minus 15 to a negative infinity. So let's go ahead and wait until the end. So let's just forget about our limits for a little while. Let's just integrate u to the negative 3, which is going to be u to the negative 2 divided by your new power. And we'll put our x's back in. So this is negative 1 over 18. And this u to the negative 2, let's move that to the bottom, so u squared. Oh, I still didn't put my x's back in. So let's try again. 1 over 18. Put in my x's back in, so that's 9x minus 15 squared. At this point, let's say we want to evaluate it from negative infinity to 1. Now it doesn't really matter at what point you guys put in the limit. I probably would normally do it a little bit before, but let's go ahead and write it now. So let's do the limit, and we still have our negative 1 over 18 times 9x minus 15 squared. Evaluated. Here's my 1. That negative infinity is what's giving me trouble, so let's make that an a. And we'll say it says a goes towards negative infinity. So let's go ahead and put an a in. So this will be the limit as a goes towards negative infinity. Now our textbook puts an a when it's the lower limit. You could still make it a b. It's not going to make a difference at all. We want the limit. Let's plug in the top limit first. So it's negative 1 over 18 times 9 times 1 minus 15 squared minus a negative 1 over 18 times 9 times a minus 15 squared. Let's simplify a little bit. So the limit as a goes towards negative infinity. Okay, this negative 1 over 18 times 9 minus 15 squared, let me put that in my calculator, as negative 1 over 648. Okay, minus the negative is going to be a plus 1 over 18 times 9a minus 15 squared. Okay. Now we see what would happen if we put in a negative infinity here. So what would happen if this went towards negative infinity? Okay. So we'd have 9 times negative infinity, so that's going to be even bigger. So if we had negative a million, now we have negative 9 million. Minus 15, that's going to be like negative 9,000,015 times by 18, and we're up to really, really big numbers, okay? And so no matter, oh, and we forgot to square it, so it's going to be really, really, really big. So when we're putting this in, even though it's a negative, that's not really affecting us. We're still getting really, really, really big numbers. So when you divide by really, 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 really big numbers, that whole part goes to 0. So all that's left is negative 1 out of 648, or 0.00154.